How you doing? I know you are doing very, very well. Extremely well by the grace of God. And I'm so excited to see you again in this lesson. And I know you haven't forgotten about the things we have learned so far. Please keep track of all the things we are doing. Now, we are looking at types of forces, and today our attention will be on spring force or spring forces. Spring forces. You know, when a force is exerted on a spring, normally what happens is that either the spring will stretch or the spring will compress. Two things. Anytime a force is applied to a spring or forces are applied to springs, two things that you see happening to springs. They either stretch or they compress. Now, the spring will want to fight back. Do you remember action and reaction? The spring will fight back. And the force that the spring, a stretched spring or a compressed spring, and let me repeat it. The force that a stretched spring or a compressed spring will also exert on the body that is hung on it, or the body that is exerting the force on it. That force is simply called spring force. Oh, come on, let me demonstrate it here. I will show it here and I will demonstrate it for you to see. I have this spring. Then I just suspend this body on it. And this is what happens to the spring. This is the body. Now, this body is stretching the spring. And you can see from here. This body is stretching the spring. Now, this spring will also try to exert a force on this body, causing it to stretch. The force, this body which is causing it to stretch, this spring will also try to fight back. This is what I mean. And the force in this spring that is exerted on this body that is stretching it, that force is what we call spring force. I want you to take your mind back. Please, we are doing interconnectivity here. We don't learn anything in isolation. We don't learn anything in isolation. Let's see how a spring force and other forces are connected. Can you tell me the force of this body stretching the spring? Do you remember that? That is the weight. That is the weight. So the weight of this body is what is stretching the spring. If the spring will also want to exert a force on this body in a way to oppose this force, then that force is simply tension. Do you remember that? It is the tension in this spring that will try to restore the spring back to the original state. I'm saying this, that this body will not just exert force on the spring and get away with it. It can never happen. Because when there's always an action, there's also a reaction to it. Anytime there's an action, there's always a reaction. So when this weight exerts a force to stretch it, the spring will fight back. And the force that this spring will also exert on this body is what we are calling spring force. And as I said, when you delve deep into it, simply is talking about the tension in the spring. Tension. So can't we say this? That tension in a spring is an example of a spring force. Tension is an example of a spring force. I will demonstrate it. So for an illustration, I have this spring. You can see it. And I suspend this spring on this rod. So the rod is acting as a support. Now look at this spring. Then I suspend this body on the spring. Come on, look at it. The spring has stretched. There's a force stretching this spring out, and I'm going to call this force tensile force. In actual fact, what is the force stretching it? It is the weight of this load. The weight of this load that is stretching it. As I said, this spring will not allow this weight to act on it and get away with it. It can never happen. Because therefore, to every action there is a reaction. So what this spring will do is to fight back and come back. Now, I will show you something here. Watch this carefully. I'm going to move this one a bit down. What happens? What happens? The spring is trying to come back, trying to draw itself back to the original state. And that's the force the spring is exerting. The spring is also exerting force on this body to draw it back up. And by so doing, you will see this body oscillating. The force in the spring, which is exerted on this body, is what we are calling the spring force. Are you okay? All right. Enough of this. So we can talk about the next force, which we call the thrusts and then the upthrusts. So the thrusts and the upthrusts, as I said, are the next forces we are going to look at. The next forces. First of all, let's talk about what we mean by thrust. Thrust is a force. Look, no matter the name you hear, the moment you are told that we are looking at types of forces, it means that whatever you write is simply a force. They may have different names, but they are all considered forces. Now, what is thrust? Now, if I have a force, and what the force seems to be doing, or what the force is doing, is that it is acting perpendicular to a surface. That force is acting perpendicular to a surface. If a force will do that, then we shall call that force a thrust. We shall call that force a thrust. So I have this surface. Let me take this surface, and I have a force, two forces, one acting F1 this way, and I have this force acting F2 this way. Now this force F2 is found to be perpendicular to the surface. Then I'll call F2 a thrust. Are you there? A thrust. Now, then from here, we move to the force we call up thrust. So simple. Now, you understand the word thrust. You understand the force we call thrust. What about this word up? It means that it is first of all perpendicularly acting to a surface, but it is pointing vertically up. Come on. The force is going up and perpendicular to a surface. Now, the fact that a force acts perpendicularly to a surface means that that force is simply called a thrust. But up thrust means that it is acting perpendicular to a surface, but vertically up. And so a force, an up thrust, is simply a force that acts upward perpendicularly to a surface. Perpendicularly to a surface. Now, this upthrust we are talking about, in actual fact, occurs in fluids. I've given you the general term we call upthrust, but it only occurs in fluids, and prominently it occurs in liquids. You know, when we talk about fluids, we're talking about liquids and then gases. But you ask yourself, can you show me the surface of a gas? In this room we have gas. In this room we have gas. We have air. Can you show me the surface of air in this room? But you see, we have water also here. We have water in this room. Water is also a fluid, but water has a surface. So you see, upthrust we are talking about, prominently, as I said, is referred to a liquid, an upward force that acts perpendicularly to the surface of a liquid. Even though it is an upward force that acts perpendicularly to the surface of a fluid. And as I said, to understand it better, liquids are the ones we use for clarification. Now, when we talk of a liquid, I have this container and I have this liquid. This is a liquid in this container. You place an object on the liquid surface. Listen to me carefully. I've said it, that to every action you will see a reaction, a response. Now, this body you see here, the weight of this body will try to push the body through the liquid. Do you know what is happening? The weight is exerting force. The weight of this body, this weight, W, of this body is trying to exert a force on the liquid. And you can't just exert force and get away with it. It can never happen. There's always going to be a response. And the response here is that this liquid will also give you a force we call the upthrust to hold you in check. To hold you in check. Now, if this upthrust and the weight are the same, that body will float. Nobody is stronger than the other. We overcome each other because we are equal and we are opposite. And what happens to the body? The body floats. Can you see the container here? Can you see it? I have this ball resting peacefully on the surface of the water in this cup. And I know you can see the water in it. You ask yourself, why is the ball not sinking to the bottom? Why? If there is no force from the liquid, from this water, to oppose the weight of this ball, the ball will sink. Now, if the ball is not sinking and the ball is floating, it means that then this liquid is also reacting with an upward force, something to counter the weight of this object, this ball. And the ball floats. And as I said, once the ball floats, it means that the upthrust from the surface of this water and then the weight of this ball are equal in magnitude, so they cancel each other. And so once they cancel each other, there's no resultant force on it. The ball will stay. Even if the weight of this ball is bigger than the upthrust, and I'll go to the ball to demonstrate it. If the weight is bigger than the upthrust, what will happen is that the ball will have to sink to the bottom. But you see, the upthrust is still there to check it. And so even though it will sink, it will do so slowly because there's something holding it in check. Can you see that? Look, you leave a ball in air. Just leave a stone or any object at all in air. Allow it to fall and see the speed with which it will hit the ground. Just drop the same object in water and check how long it will take for that object to hit the bottom. It tells you that there's something in the water that is trying to hold in check the weight of that body which is drawing the body down to the bottom of the liquid. There's something in there. And that is what we are calling upthrust. Upthrust. So we define upthrust. We define upthrust as simply an upward force acting perpendicularly to the surface of a fluid. An upward force that acts perpendicularly to the surface of a fluid so as to hold in check whatever placed in the fluid. Can I repeat it? It is an upward force that exists at the surface of a fluid to hold in check whatever placed in the fluid. Now, I will tell you something very interesting. This upward force is simply called buoyancy force. This upward force is sometimes called buoyancy force. And I will tell you something very interesting. This upward force is sometimes called the buoyancy force. Now, so interesting. This is water. Now, anything you place on the surface of the water will experience the upthrust. Of course, the weight of that body is there. When I heard of this reportage in one of those articles, I was amazed. And what I read was this, that we are told in the scripture that Jesus walked on the sea. And the explanation this article is giving is this, that Jesus walked on the sea at the time that the upthrust of the sea was bigger or equal to his weight at that time. That is why Jesus did not sink. The point I'm making is that physics would do everything possible to explain everything in nature. Physics is explaining almost everything around you. I'm telling you. Even things that your eyes cannot see that we consider spiritual, physics will try to explain it. Physics is the root of science. And I get marveled that Jesus could walk on the sea at the time that the buoyancy force or the upthrust was equal to his weight. That is why he could not sink. And the explanation again they gave was this, that during that time, it was during the winter time that the temperature was so low. And normally during winter times, when temperatures are low, water is denser. Water is denser during that time. And once water is denser, it means that it's upward. Upward force we call the upthrust will also be big. The last thing I want to say is this, that upthrust is not constant. When I take a liquid, the upthrust at the surface of that liquid is not constant. You know why? Archimedes says something, and I'll end it here. Archimedes says something, that if you put an object in a liquid, watch this. Can you see part of this body submerged? You can see it. Part of it is submerged. What it means is that that part which is submerged inside the water has gone to displace the water, and it has occupied that space. That part which is submerged has gone to displace water and has occupied that space. Now, if we can capture the amount of the water which is displaced, and we find the weight of that water which has been displaced, it is equal to the upthrust. Do you know what it means? It means that the more liquid you can displace, the bigger the upthrust. No wonder those who swim, swimmers don't sink, they float. Now, as they swing their arms, they displace a lot of water. And as they displace a lot of water, if they can capture all the water displaced, and they can find a weight, that weight is simply the upthrust. So the more water they displace, the bigger the upthrust. They can never sink, they always float. You know why ship will always float? It is because when the ship is put in the sea, that ship will also displace some water. And the amount of water displaced gives the water a bigger upthrust to hold on, to hold the ship on the sea. Look, I said it, that physics is so interesting that I always say this, that you can't do without physics. You can't. It explains nature. It explains everything around you, to the extent that it is explaining how come Jesus could walk on the sea. Look, I won't say anything again, but I will see in my next lesson.